A long time ago, in a galaxy far, far away, there lived a girl named Judith, and her main mission was to teach about chemistry. Well, to be more specific about the radiation electronegativity down the group. Well, for the average Joe out there, you may wonder, what is electronegativity in the first place? Electronegativity is the relative tendency of an atom to attract electrons to itself when chemically combined with another atom by a chemical bond. Well, to put it in simpler terms, it is the force or the ability of an atom to attract electrons. So here is an atom that consists of electrons and nucleus. The electrons are able to orbit the nucleus due to the attractions of electrons towards the nucleus. So how does electronegativity come into play? So here are two oxygen atoms combined with a carbon atom to form a carbon dioxide molecule. Both of them share 2 electrons each, and each of them now has 8 electrons. The problem here now is both of the atoms want to pull the shared electrons towards themselves. But who will win the tug of war? Well, the answer depends on the electronegativity of the atoms. The electronegativity of an atom depends on its atomic structure. So let us take a look at a periodic table. Across the row is known as a period, and down the column is known as a group. In the chemistry world, the electronegativity of elements decreases down the group. But why is that so? So let us get the main idea. Down the group, the atomic size of elements increases and leads to the increase in distance between the outermost shell and the nucleus, and will result in the weaker attraction of electrons towards the nucleus. The nucleus will exert less force towards the outermost shell, causing the electronegativity of the element to decrease. To further clarify, as we go down the group, the number of shells filled by electrons increases, causing the shielding effect to increase too. This will then result in a weaker attraction between the nucleus and the valence electrons because the outer electrons are held less tightly to the nucleus. When the distance between the nucleus and valence electrons increases, the atomic radius also increases, which leads to the weaker ability of the element to attract bonding electrons to itself. Thus, electronegativity of the element decreases. Shielding effect is caused by the mutual repulsion of electrons for each other. The most widely used scale is developed by Linus Pauling. He assigned the most electronegative element, fluorine, a value of 4.0. If you remember that fact, everything becomes easy because electronegativity must always increase towards fluorine in the periodic table. To enlighten you with an example, lithium up to francium are alkaline metals in which their electronegativity decreases down the group. To summarize, the electronegativity of elements decreases down the group. Now that I've completed my mission, I bid farewell.